morning, guys and gals. Happy Friday to you. Hope everybody's healthy, wealthy, and wise on your end on this rainy Friday morning. Today, ladies and gentlemen, we're going to continue with the current problems and the wind problems. But I'm not going to lie to you. Yesterday was the intro. Today's one or two extra steps. But the main ideas really stay the same. You really want to make sure you're with me with the first three examples. We're going to do three today just to make sure that we're good to go. After we knock out our three examples in our in our notes, we do have a 4-question homework. You kind of know how that's going to roll. So without further ado, let's do this thing. Watch the screen. Hey, you guys know by now this is a perfect time to pause the video, grab yourself a pencil, piece of paper, and follow along. Okay. As stated, these are harder, but a lot of things stay the same. Oh, sorry about that. A boat traveled 108 miles downstream and back. The trip downstream took 4 hours. The trip back took 12. What is the speed of the boat in still water? What is the speed of the boat of the current? Okay. So we're still looking for speed, and we're still looking for speed of the boat and current. So my declaration doesn't change. I'm going to make X my boat and Y my current. Okay. That part doesn't change. Now this setup, you really want to make sure that you're with me here. A boat traveled 108 miles downstream and back. So whether it's with the current, it's going 108 miles. Whether it's against the current, it's going 108 miles. What changed is the time. Okay? So, once again, work with me. The trip downstream took 4 hours. The trip back took 12. So downstream is less time. That's with the current. So I'm going to put in parentheses X plus Y. So the boat plus the current equals 108 miles. But you might say, well, mister, that's just like what we did yesterday, but with the parentheses. I agree, we have to include the 4 hours. We have to take our boat speed and our current speed added together and multiply it by 4 hours. Okay. Don't distribute. I would have you distribute if we were in class together, but since it's through videos, I'm going to show you the easy way right away. Okay, let's set up our other equation. The trip back took 12 hours. So that's against the current. Instead of X plus Y, this will be X minus Y. It still equals 108. And I know a lot of your brains are going to start to say, wait a minute, what, Mr. Herr? It still traveled 108 miles downstream and back. The mileage is still the same, but what's different is the amount of time it took. Okay, it took 12 hours. So we're going to have X minus Y, that quantity, times 12. You could distribute the 4. You could distribute the 12. It's not wrong, but I also want to show you an easier method. Okay. What I'm actually going to do is I'm going to divide both sides by 4. Okay. The way these are set up, guys and gals, it's going to work out pretty nicely. Okay. Hey, the 4's cancel. Good. We're left with X plus Y equals 108 divided by 4. Hey, that's 27. Okay, I'm just rewriting that over here. X plus Y equals 27. I can work with that. All right. Same deal down here. I could distribute the 12, and it's not wrong, but you're working harder than you have to. Divide both sides by 12. X minus Y equals 9. Hey, I'm going to rewrite that up here. X minus Y equals 9. Now it's just like yesterday. Literally, we already have opposites. We're just going to add and go. The reason we can do that is because we have positive y and negative y. Those opposites are going to cancel. We get 2x equals 36. Divide both sides by 2. X equals 18 miles per hour, and that's for our boat. Okay. You can plug it into the original. Personally, I know I divided right. I'm going to make sure that I plug it into one of these. Specifically, the first equation, 18 plus y equals 27. Subtract 18 from both sides. Y equals 9 miles per hour, and that was our current. Let's just do some quick math. 18 plus 9, 27. Check. X plus y, 27. Yep. X minus y, or 18 minus 9 is 9. Check, check, check. Hey, trust me when I say, if you distributed, it's not wrong, but I'm showing you the easiest way. I know you might not believe me, but I promise you I am. Okay. Number 2, same idea. A boat traveled 63 miles downstream and back. Okay, that's going to be important. The trip downstream took 3 hours. The trip back took 21. What? What is the speed of the boat in still water? What is the speed of the boat? What is the speed of the current? Sorry for the stutter. My bad. Still going to declare. X is my boat. Y is my current. Okay. It's the setup that's hard, so I'm going to slow down a moment here. A boat traveled 63 miles downstream and back. So with the current, 63 miles. Against the current, 63 miles. The trip downstream took 3 hours. That's the speed here, so that's x plus y. It's with the current. They still traveled 63 miles, but it took 3 hours. So I'm putting that in parentheses, and I'm multiplying it by 3. The trip back took 21 hours, so that's against the current. X minus y equals 63. And I'm going to multiply that by 21. You could distribute the 21 and the 3. I beg of you, don't. Make life easier on yourself. Those cancel. We get x plus y equals 21 when you divide by 3. Divide this equation, both sides, by 21. We get x minus y equals 3. Once again, now we're ready because plus y minus y, that's what we like to see. The y's cancel. We get 2x equals 24. Divide both sides by 2. X is 12 miles per hour, and that was our boat. Personally, I like the first equation better. 12 plus y equals 21. Sorry for being off screen. Subtract 12 from both sides. Y equals 9 miles per hour, and that was our current. A quick double check. 12 plus 9, or x plus y. Yep, 21. X minus y, or 12 minus 9. Yep, that's 3. Okay. Hey, one more with a plane. I'll go quick. Hopefully, though, don't leave you behind. Okay. The numbers are going to get bigger in this problem. Have no fear. The old man's here. A plane traveled 320 miles to Cairo and back. The trip there was with the wind. It took 4 hours. The trip back was into the wind. It took 8 hours. What is the speed of the plane in still air? What's the speed of the wind? Okay, let's do this. X is plane. Y is wind. Once again, it's the setup, kids. That both equations are going to be equal to 320 miles. A plane traveled 320 miles to Cairo and back. Okay, the first time was with the wind, so x plus y equals 320. And how long did it take? Well, it took 4 hours. Okay, the trip back was against the wind, so x minus y, the wind is slowing it down. They still traveled 320 miles, but it took them 8 hours. Now we're set up, let's go. Instead of distributing, I'm telling you, go the easy way. Divide both sides by 4. The 4's cancel. We get x plus y equals 320 divided by 4. That's 80. Love it. Here, you could distribute, but divide. The 8's cancel. We get x minus y equals 40. Hey, we're ready. positive y, negative y, add these things and go. We get 2x, the y's cancel, equals 120. Divide both sides by 2. X equals 60. Okay. Well, if x is 60, let's plug that in. 60 plus y equals 80. Subtract 60 from both sides. Y equals 20. Specifically, miles per hour, and that was our wind. Oh, and almost forgot my label. Miles per hour, and that was our plane. Now, hopefully the plane's going faster than 60 miles per hour. Otherwise, it wouldn't be in the air. That's a whole nother issue for a whole nother time. You can double check your work. 60 plus 20, 80, 60 minus 24. Good to go. All right. Hope this has helped, guys and gals. TGIF. Have a great one. Peace.